Hello friends, welcome to the channel Physics by IITians.
Hello friends, this is the important revision class of nuclear physics lecture number 3. So I assume that you have already watched the previous two videos and I think those are kind of helpful for you. So let's start today's videos. In this video, basically I shall discuss the another model, that is collective model. Now from the name collective, you know something that is collective means this is called also unified model. This is a description of atomic nuclei that incorporates aspects of both the shell nuclear model and the liquid drum model, and this will explain the certain magnetic and electric properties that neither of the two separately can explain. So that's why this model is known as collective model. So this is actually unification of both the two models that we have already discussed. So this is the collective model of uranium nucleus. We shall derive this the different terms that O plus, 0 plus, 2 plus, 4 plus. What are those? In this lecture I shall tell you. So first of all, the why do we need collective model? So the liquid drum model fails to explain spin, magnetic moment, magic number, but shell model cannot explain deviation of magnetic moment from a Smith limit and large quadrupole moment of certain nuclei and fission, fusion it cannot. So we can think of the some more model which will going to tell each and every phenomenon. So here in this collective model, we assume that the nucleus consists of a central core and some extra nucleons. So suppose this is the central core and around this core there are number of nucleons that are extra, and within this core there are a number of nucleons. These numbers are the magic numbers. Okay. So what is the effect of this extra number of nucleons which are outside the core? So we can think this extra nucleons have large centrifugal force on this core, and if their number is large, means if the extra number of nucleons are quite large in amount, they can deform the core, and the total energy of this deformed nucleus can be written as En plus Ev plus Er. Now what this terms En is due to the extra nucleons, Ev is due to the vibrational motion, Er is due to the rotational motion of this nucleons, and the rotational energy, that is Er, is directly proportional to I into I plus 1, where I is the spin of the rotational state. Okay. So here what is the most important thing? You have to remember the rotational energy expression for the nucleons, and which is I proportional to I into I plus 1. So let us find out some problems to solve this kind of questions. First of all, before solving these questions related to the shell model, we should know about the gyromagnetic ratio, and we should know about the G factor. How do you calculate the G factor for the nucleons, means for the proton, for the neutron? So suppose us consider a nuclear level corresponding to a closed shell plus a single proton. So there is a level, the closed shell, it is already there, plus one extra proton, the single proton, in a state with the angular momentum quantum number L and J. So of course we know J equals to L plus half or L minus half, depending upon the spin orientation of that proton. So let us take Gp be the empirical gyromagnetic ratio for the free proton, and compute the gyromagnetic ratio for the level in question for each of the two cases, J equals to L plus half and J equals to L minus half. What will be the gyromagnetic ratio? So if we think of the shell model, which we have already read, the total angular momentum of the nucleus of the closed shell is 0. Only we have to account for the extra shell which is outside the closed shell, right? So that will going to give you the magnetic moment, the angular momentum of the nucleus. So first of all, mu j, that is the total moment is the sum of mu L plus mu S, that is due to the orbital moment plus due to the spin moment, and Gj into J can be written as Gl into L plus Gs into S. So just remind the lectures which I have already given on the atomic and molecular physics. There also for the electron case we account for these terms mu J, mu L, mu S, Gj, Gl, Gs. Okay, all right. So here we have Gj into J is Gl into L dot J plus Gs into S dot J, where L dot J can be written as half of J square plus L square minus S square, or J square can be written as J into J plus 1, L square can be written as L into L plus 1, S square can be written as S into S plus 1. Similarly, S dot J can be written as half of J square plus S square minus L square. So Gj is this term, that is Gl into J plus 1 plus L into L plus 1 minus S into S plus 1 divided by 2J into J plus 1 plus Gs into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. So only these two terms, that is L dot J and S dot J, these two terms are here given, these expressions. Now for proton, we have to calculate the single. So for proton, Gl equals to 1, Gs equals to Gp. So gyromagnetic ratio for free proton, where L equals to 0, J will be equals to S and S equals to half. So we can write that this you put here, that is L equals to 0 and J term only will be S. Gj will become 2j minus 1 by 2j plus gp by 2j for j equals to L plus half, and 1 by j plus 1 into j plus 3 by 2 minus gp by 2 for j equals to L minus half. So you have to remember these two formula for the gyromagnetic ratio, where j equals to L plus half, you have to consider this one, where j equals to L minus half, you have to consider this one. So friends, we have an announcement that you can give full length test, you can give subject wise test, the minimum cost, and it will take only 699 rupees. And also there is special interview guidance for those who want to crack integrated PhD MTech interviews. They can have the subscription with the only rupees 699 for 1 year, and those who have already joined our test series, for them the offer is exclusive and this will only 500 rupees for 1 year. Contact us on Telegram for more information. So let us take some examples so that you understand how to calculate the nuclear magnetic moment, how to calculate the magnetic dipole moment. Okay, so suppose we take here two examples, the magnetic dipole moment for calcium 2041 and the magnetic dipole moment for strontium Sc2141, where nuclear magnetic moment is given by mu equals to Gj mu n, where mu n is the nuclear magneton. So how to calculate the magnetic dipole moment of any nucleus? So first of all, this calcium 41 has a neutron extra and strontium has a proton outside the closed shell. Okay, so what we have to account? We have to account the extra or outside the cell, that nucleon on we have to account for our shell model. So shell model, you configure this 41 and this 41, and you will get that the closed shell in this state, that is the state which is unpaired proton or unpaired neutron for case of calcium and unpaired proton for this case of strontium, it is has state 1f7 by 2. So in the last lecture we have already described how to configure this shell, nuclear shell, and how to find out the outside this expression. Okay, So these closed shells do not contribute to the nuclear magnetic moment, but the extra shell nucleon will contribute. So the nuclear magnetic moment is given by Gj into mu n. First of all, I have given you how to find out G value. You have to find out G value from this expression. Where J equals to L plus half, you have to consider this one. Where G equals to L minus half, you have to consider this expression. Now for this calcium 41, we have one unpaired neutron. So for neutron, Gl equals to 0, Gs equals to Gn. Okay, and for proton, the Gl equals to 1 and Gs equals to Gp. These are the differences. So here Gs equals to Gn, that is equals to minus 1.91 divided by 1 by 2. Here you just put this one. Either put the value of GL, put the value of GS, put the values of J, and you will get minus 3.82. Why I have given this formula? Because look here, this is 1F7 by 2 states. Now J equals to 7 by 2 and L equals to 3 because F term. So 3 plus half is J value, that is L plus half is J value, that is 7 by 2. So we have to apply this formula. Clear? So we have for calcium 41, mu 2041 calcium is minus 1.91 mu n. Okay. So first find out Gj and then calculate the mu value. Suppose we are taking this for the proton for this case, strontium case. So you take this proton is the unpaired proton and this is proton has a GL value as 1, GS equals to GP as 5.52. So J equals to 7 by 2, that is L plus half. So 3 plus 1 by 2. We also have to apply this formula. So apply this formula, you will get 5.79 mu n. So in this kind of questions, you have to first look for the G values, and for that you have to apply the particular J value, which is L plus half or L minus half, and then put the formulas, put the values, and you will get the answer. That's all. Another question is from collective model. So the question is the band spectrum of uranium-238 based on ground state, that is 0 plus. If the energy of 2 plus state is 44.7 kilo electron volt, what is the spin and parity of state having energy 5.25 kilo electron volt? So the energy of the state 2 plus has been given as 44.7 keV. You have been asked that what is the spin and parity of the state having energy 5.25 kilo electron volt. Is it 2 plus? It is 4 minus? It is 6 minus? It is 8 plus. So here, since we have this formula, that is EI is proportional to I into I plus 1. So, or you can write as EI equals to K into I plus 1, where K is a constant. And suppose we take it as a 1 for the first state, E1 as K into 1 plus 1. We can take E2 as K into 2 plus 1 for the second state. So E2 can be written as K into 2 into 3. So take this ratio, that is E2 by E equals to 6 divided by I into I plus 1. So you get 6 divided by I into I plus 1 equals to, here E2 is 5.25 and this is 44.7 keV. Okay, this is 5.25 actually here. So okay, this is 525. Okay, because this is energy is 525, not point here. This is 525. This is ground state 44.7. So this energy has higher state 525. So 525. So compute this value, calculate. You will get I equals to 8. Now I cannot be minus 9. I cannot be negative in this collective model. So the spin is positive and this is plus 8. So ignore this 5.25 value. This is 525 value, 525 keV. Okay, let us take some other examples so that you understand. Suppose we are taking this level. So the rotational energy level of an even nucleus are 0 plus ground state, energy of 2 plus equals to 44 keV, and the higher energies are 146, 306, 514 keV. So ground state energy here, even nucleus, ground state is 0 plus, and the energy of 2 plus is 44 keV. So higher states are 146, 304, 514 keV. What will be the parities, spin parities? That is, you have to apply this one, that is EI is proportional to I into I plus 1, or it can be written as EI equals to I plus 1. E2 is given here. E2 equals can be written as K into 2 plus 1, that is 3, or E, that is which you want to find out, you can take this as I. So K into I plus 1. So 2 is for this one, 2 plus, and I is for next higher for which you want to find out. So the next higher order I is 4 and spin parity is positive. Similarly, if you take the ratio of E2 and E3, then take the E2 as this one and E3 as I. Okay, and then you will get the next spin is I equals to 6. For the next one, E3 by E4, take the ratio you will get for the next is I equals to 8 and 8 positive. So in the first diagram, I have shown you this one, that is 0 plus, 2 plus, 4 plus, 6, 8, 10, 12, 14. So do you get the here? Look here. You will get 0, then 2 plus, 4 plus, 6 plus, 8 plus, and so on. Okay. So in this question, they ask you about I, that is the higher spin and higher order spin and parity of the higher energy. But they are also, suppose they have given you the spin and parity, that is they have given you the two values, 2 plus and 4 plus, and they can ask you calculate the energy for 4 plus level. Then you also have to apply the same formula. You only have to find out this E value and where 6 and this I will be given. Okay. Suppose we are taking another example for the liquid drop model, which we have already discussed. So here the question is, for what elements should stable isobar exist for A equals to 97? So first, what is the question? That is the what will be the stable isobar that is for mass number A equals to 97. For whenever you face such kind of questions, the stable isobar, you should apply the semi-empirical mass formula, that is ZMA, and it can be written as ZMA equals to Mn A minus Z plus Mh into Z minus Av into A plus As A to the power 2/3 plus Ac Z minus 1 e to the power minus 1/3 plus Aa A minus 2Z whole square A inverse plus minus Ap A to the power minus 3 by 4. Now substitute these values of these constants like AV, AS, AC, AA, AP, Mn, Mh in MEV. They will give you these values in mega electron volt. You have to substitute these values. So Mn is 939.6 into A minus Z. Mh is 938.8 into Z. AV 14. AS 13. AC 0.60, AA 19, AP 34. So for the most stable isobar, del M by del N at Z equals to ZA should be 0. Okay. So you take Z, then you find out, calculate the value of ZA. You will get ZA equals to 76.8 plus 0.6 a to the power minus 1/3 divided by 152 plus 1.2 a to the power 2/3 into A. Now for odd value of A, now look here, A is given as 97. So put here the value of 97. That is ZA equals to 42.7. So whenever the mass number is 97, any isobar which has the atomic number nearer to 42.1, it will be the stable isobar. So the atomic number nearer to 42.1 is 42 molybdenum. Okay, so the most stable isobar is 42 molybdenum 97. So in the previous video I also have discussed such kind of questions. So I think you understand what we have to do. We have to basically apply this formula. Okay, and if you apply this formula, you find out the atomic number, and from that atomic number, which atomic number is nearer to this most stable atomic number, that will be the most stable isobar. So friends, thank you for watching this video. You can have access to a free test in our portal. The portal link is given in our video link also. So in the below of the description section of this video, you will get this. You can give a free test, you register yourself, and also you get the full solution. So thank you for your cooperation. Hope you find our videos helpful. Please do share our videos, do share our channel, do join our Telegram channel for regular quiz updates, subscribe to our channels for regular updates, and don't forget to follow our channel regularly. Thank you.